So my name is Robert Gray, right up there. Robert Gray III. I work for Daimler Trucks North America. I'll be speaking on aspirations of machine learning. So I know that that's kind of a vague title. At the very end, or very late in developing this presentation, I was informed that the use case I was planning to present would not be allowed to be presented to you all that are not within the company. So I kind of wanted to speak to a more high level, speak to some of the um, uh, strategy and shifts in culture that needed to take place in order for us to be able to build a model, train a model, and be able to deploy it for business reliance and usage. So that's kind of where we are there. Um, I'm sorry, I guess I should also give you a little bit of background. So I'm Robert Gray III. I'm a technical delivery manager for Daimler Trucks North America. I focus more so on digital transformation. So as you can imagine, as of this year, AI, machine learning, deep learning, neural networks, it's been a deluge of discussion and how we can make use of it in order to improve our business processes. Um, Yep, right here. Okay, my apologies. Can everybody hear me okay? Is that better? All right, perfect. So just going through the agenda here, kind of going through a brief introduction of ML, the importance of strategy behind ML, and how to deploy it, identifying problems and technique, your data, choosing your model, hyperparameter tuning, training versus test data, as well as model deployment and monitoring, and then we'll wrap it up. So bear with me. So first thing, a little bit of a complex slide. I realized that it didn't translate too well as it was on the big screen there. This is not an OLED. I got a nice gift last Christmas, so it looked a lot better on my computer, and I thought it would translate better. But so first question that I have, does anybody, has anyone ever worked with machine learning? You have? Okay, a few of you. In what capacity? Have you built the model or just more so been the recipient of it, tested it, trained it? So, okay, so cool, we've got some people. How many of you have never done anything with machine learning outside of read the words machine learning? Yeah, nobody? Oh, okay, all right. Okay, perfect. So machine learning is not exactly AI, all right? It is a subset of AI that is more focused primarily on prediction and decision making, right? It as opposed to deep learning, which is more so focused on pattern recognition and noise cancellation. So the way that you could think about it is if AI is the concept of a vehicle, machine learning would be the concept of a car that you can ride around on the street, whereas deep learning would be a magical vehicle that can just do everything. Right? It can fly, it can go in the water, it can do it all. All right. Machine learning has the most application in terms of business processes, just from a implementation standpoint, being that AI is a little bit too broad in general for most companies, and deep learning is a little bit too niche and segmented for those same companies. Machine learning, on the other hand, leverages data, process, and decision making, and allows working level users to make those heavy decisions of their own accord without the need to rely on higher management. In terms of, or let me move to the next one. So in terms of technology and capability, the technology exists, and I'm sure with most companies you actually have the capabilities to implement a machine learning model. However, it is not a simple thing to do for multiple reasons, a few of which I'll speak to here. The first thing is it even worth it all the time? And many times it is not. Machine learning should more so be utilized when traditional programming cannot meet the demand of what the business needs to get done, right? For all intents and purposes, if you can solve the problem with traditional programming, solve the problem with traditional programming. Trust me, it's not worth it to go through the coordination of doing it. However, if there is a problem, right, that you understand as a problem and are able to identify the limitations of traditional programming as why that problem can't be solved, you may have a very real use case for machine learning. In order to make use of machine learning, you need to have these three components, right? I'll actually go in reverse. We'll do a 3, 2, 1. First, you have identified you can't solve the problem through traditional programming, right? I can speak to a little while ago, we had we were rolling out a new program, and the way that we had to test that the program was working was we actually had to go out there and count the parts and then ensure that the same number that we counted was showing up in the system. It was tedious. It was nice because we got to move around. You know, we sit at our desk a lot, so I got some exercise. But it couldn't be solved through traditional programming, right? And this was a few years ago. Machine learning wasn't as mainstream as it is now. But that's that. Pattern recognition or predictive modeling, right? If you can identify a means to, which essentially would be, say, a standardized nomenclature or an understanding of this versus that, right? A versus B across the board, right? If you can segment and cluster those those components, then you have an opportunity to build something there. And the most key is the lifeblood is you need a big data set, right? You need to have a lot of data for to train a model, right? It needs to be able to understand what the difference between what it's looking for and what it's not looking for in various contexts is. If you have those three things, if you can go in and have those three things, you can make a case for machine learning. You can go to your manager and say, hey, look, we need to make a machine learning solution, and then you'll sound really smart and really forward thinking, and you know, people will look at you like you're Tony Stark or something. All right. But also, part of the strategy is you want to start small. You don't want to build a model that is going to have completely revolutionize the company, because again, it's going to be worth more trouble than it's worth. You need to start small. You need to do something small. If there are any product managers in the room or traditionally trained product managers, this will be your MVP, right? You want to identify first what the need is, what the outcome should be, and how the business will make the most use of it, and then identify what you can give them. Not necessarily the features, functions, bells, whistles, all of that stuff. You need to figure out what the most, the minimum thing that they can make use of will be. So you want to start small and, if possible, simple. You want to start as simply as possible. Oops. Okay, so this is going to be far more challenging than developing anything, any type of coding, any type of programming, any type of technology implementation. Compared to getting the culture on board with what you're trying to do is going to be simple. Everything that we have to make use of machine learning methodologies, machine learning use cases, machine learning outputs, it's available. The biggest impediment to it is culture, right? Especially with starting with last year, December, with the rollout of ChatGPT, and now you have all these other things like Midjourney, and I just heard that Snapchat released an AI. People are, it worries a lot of people who don't fully understand it, right? People are afraid that they're going to lose their jobs. They're afraid that they're going to be replaced by a robot, and you know, I'll tell you guys now, from a person who's spent a fair amount of time studying it, I don't think that's going to be the case, right? This is no different from a few years ago, say in the early 2000s when Google became commonplace, right? It's not a matter of whether it's going to take your job or not. It's what the most key difference will be is the professionals who can functionally and actively make use of it, and those who cannot, right? If you can actively make use of machine learning, AI, deep learning technologies, by orders of magnitude, you are that much more productive than the counterparts who cannot, and that's where the fat is trimmed, right? It's not going to remove jobs. It may remove some, but it'll create others and better and more effective and fulfilling and cool jobs, right? I mean, anytime I tell people I work on machine learning engineering, they're always, it's like their eyes light up, right? It's just it's like the cool thing to be involved with right now. So that's really just getting the company on board, right? The reason that this is going to be so difficult is because in order to actually functionally deploy it, you need to have buy-in from just about the entire organization. The way I always think about it is like back when human beings first domesticated wolves, right? There was a lot that they needed to do in order to do that, right? They needed to train them. They needed to get them to trust them. They needed to be able to feed them. They needed to be able to say, that's dangerous over there. Here's what I need you to do, right? It was a village. It was an entire coordinated effort in order to do that. This is akin to the same thing, right? You have this intelligent thing, right? It's virtual, but it is very intelligent, and there's a lot of benefit to be had from it, but there is a training that needs to take place, and that needs to be done across multiple disciplines, right? A data team, your business competency, or your ability to speak to the business, right? The translation capability of yourself between the technical person and a business person, as well as the technical competency to meet that translation. That's going to be one of the biggest things, and the business might not always see the value in it, right? They might say, hey, look, we've done it this way for 20 years. It works. It takes us 6 weeks to get it done, but we get it done, right? Whereas what you're proposing is going to take us 10 months, and we might not even get it. It might not even happen. We might end up going back to where we are before. Oh, I thought you were raising your hand. That's the biggest thing, right? Making sure that the business is involved, and a big part of that is by telling a story, right? A compelling story, just like what I just mentioned here. Understanding that those who can make use of it are going to pull ahead, and those who don't will be left behind. Right, there were the stories of how Blockbuster refused to go to streaming, right? Just not staying in front of the technology, right? They were a giant, and now I have a 8-year-old goddaughter who has never heard of Blockbuster, but she loves Netflix. So, it's really just comes down to who stays in front of the technology, who adapts, and who does not. So that compelling story is going to be the most powerful tool that you have, getting people on board from not just from a functional place, but from an emotional place, right? Understanding that the future is changing fast, and you got to get on board with it. So again, speaking to it, that's enhancing the business as opposed to diminishing the employees, right? People will become enhanced with being able to make use of the technology as opposed to reducing their role with it. It'll just be a change. All right, so data acquisition and preparation, the lifeblood. You cannot build machine learning without a model, right? Without data. You need to have data engineers, your data analysts, your data scientists to be able to prepare, scrub, cluster, and clean that data in order to appropriately train a model effectively. Without that, you really can't train a model. Your outputs are going to be all over the place. Things are going to be different. You can kind of read it there, but again, this goes back to that big data strategy, and it's a compounded thing, right? The presenter prior to me pointed out a really good statistic to show that 85% of big data projects actually fail. They actually become ineffectual to business use or to the business units. But a big part of that is because they stop at collecting and presenting the data, right? If the data is presented and you give it to the business and they say, this is great, but I really don't know what to do with all of this, have you really succeeded, right? The success is measured in who makes use of it, not in was it completed. And that's where that failure rate comes in, right? It'll be completed, but it won't be adopted, it won't be utilized. However, that's just the first step, right? The next step is building out a model to train on that so that decisions can be made on the spot without needing to go back to senior leadership, without needing to go back to a decision board, right? Based on the data, based on the output, an individual can make the call and be confident in that because of what the model has given them. Okay, hyperparameter tuning. So this is really getting your model trained, right? This is training your model appropriately, right? This is to reduce your underfitting or overfitting, getting your noise cancellation out of whack. I'm sorry. Oh, that's us. Okay. I thought someone was asking a question. So again, this goes back to training, ensuring that your model is appropriately trained, right? Each model can be different. There are standardization of models, but they all can do different things, right? Again, tying it back to the real world. If you're training for a marathon, right, you're not gonna go hit the weights at the gym. Conversely, if you're training for a bodybuilding competition, you're not going to spend all day on the treadmill, right? It's the appropriate training. They're both fitness, but this is ensuring that your model is appropriately trained and is functionally performing as you need it to. And this is even more important because hyperparameter tuning, this ties into what a person outside of the model would give it, right? The model is only going to do what it knows to work with, but if you are beyond the model, if you are the one working with that model, then you are the one who is determining, or I'll say a human is the one determining what that model can do, what it could do, what it shouldn't do, what it will do, putting those parameters in place to train it more effectively and get it up to speed. So let me see. Optimizing the model, underfitting, noise cancellation. Yep, I spoke to Yep, outside of, so that's the user. The user will determine what critiques need to be made to the model in order to improve its efficiency. So now we get to the actual one. It's the training data versus your test data. Again, this here, this green, that's your big data, right? That's your big data set. You need to have that in order for you to reduce nuance, reduce fringes, ensure that your model is more exact, and then put it up against your training data. Oh wait, the training is the purple one. Your training data, and then you need to have your validation data. These here are a few different ones, a few different machine learning models. Personally, I have worked with a linear regression model, a decision tree model, and I thought I had random forest on here. Oh, here it is down here, and a random forest model. The one I would have liked to present to you all today was really cool. It was mind-blowing, but it was the linear regression model. Oh, okay. I thought you were raising your hand. So if anybody wants to stop and ask questions or make a statement, please do. That would help me out a lot while I'm up here by myself. So, yes.
How much is a lot of data?
How much is a lot of data? I've only ever worked with petabytes of data. But I would say if you are building out a model, so working for the Diesel Corporation, trucks produce a lot of data, petabytes of data. I don't know. I don't have an exact number for it, but I would say at least a couple gigs, at least enough to run multiple scenarios. I don't know, maybe 100 or 1,000 different scenarios to say, here's what's right, here's what's wrong, right? So it varies based on what model that you're looking to train, and it varies on how functional you want your model to be. So I can't really say an exact number, but you do need to be able to run multiple instances in order to properly train it. So this goes back to the traditional programming versus the machine learning outputs. That validation data is having what it should be versus what the model gave you based on what it was trained on. These are a few different ratios of how much you should have of each. As you can see, training data encompasses most of it, whereas test data and validation data are roughly the same, just because those are the two that you're comparing it to. Let's see. All right, last one, model deployment. It makes sense, right? You're able to deploy it in a real world scenario. You do need to functionally monitor the model, right? Anything that, learn this early on, anything that can go wrong, anything that can go haywire, it will, right? And then you'll get those things that necessarily were not even considered, but they came up. So there's always going to be a level of tuning, a level of monitoring, a level of stewardship, your information custodian work that needs to be done in order to ensure that that model stays functional, that it stays relevant, and that it continues to deploy as it needs to. Um, but if you're able to go through all of that, right, then you can really set yourself up for to scale into the future. So, conclusion, that's everything that you need to go. I'm not going to read all of that. Like I said, it came through better on the screen, but so that's what you need to learn. Like if you can make use, if you can build the technology out, if you can find the use case, build the model, and get the separate business units on board, you can really make really good leaps, massive leaps forward in terms of future planning, in terms of really scaling that business up, and also determining what decisions should be taken based on data as opposed to based on experienced leadership, right? That might have a bias or that might be less less willing to change how things have been done, right? I can speak to specifically in the healthcare environment. My wife works in healthcare, and not to scare anyone, but doctors make mistakes, right? Because they are experienced leaders who make calls, right? Whereas machine learning in healthcare, not saying that robots should take care of us, that's not what I'm saying, but they do make these calls based on data, right? If I go to the doctor and I say I have a headache, and the next time I go I say I have a stomach ache, and the next time I go I say my foot hurts, whereas a doctor may say, oh, let me treat the foot, let me treat the stomach, let me treat the head. The model itself might be able to predict and say, hey, head, stomach, foot. The next one is going to be shoulders, knees, and toes or something, So anyway, that's the conclusion. That's all of it. I would like to open the floor up for questions. I was kind of hoping this could be a little bit more conversational. If anyone would like to speak to some of the experiences they've had with machine learning or question anything that I have mentioned, I'll answer it to the best of my ability. Yes.
Share some of the value, specific value of using the data. Just speak to some of the value that you've gotten from using these large data sets and applying machine learning. Like, what are some of the types of decisions that have been improved?
So the most key is cost, right? We've been able to reduce a significant amount of cost based on a machine learning or a machine learning model that was deployed. So the value there was on cost, and it was a 7-figure return on that investment monthly. So a huge cost, huge return on that investment. Also time, right? We've been able to not necessarily have to do as much root cause analysis when we have a linear regression model in place to determine, hey, this is different on this product as opposed to this product. Oh, whenever we identify this data set, we can point to that thing. I'm trying to be vague because I was told very directly, do not discuss it. But yeah. So time and cost are the most key ones that we've been able to identify. Yes.
Can you tell us a little bit about the tools that you prefer to use when you're working on a project like this?
So I do maintain a hybrid model, right? So we do have a cloud environment plus an on-site data center. So for this one, I know the one or some that I can speak to, we ran TensorFlow to train it, Python, obviously it was coded in Python, and then sharing of the training set and the difference code with Jupyter notebooks. So just being able to save it, run the entire notebook and pass it along so that others can make changes to the code. And again, that was part of that interconnectivity of the culture. At least part of my role in it specifically was to be able to integrate those embedded data teams, right? A lot of times when you have opportunity for AI, through my own experience and through the experience and discussion with others, you'll have leaders take one of 3 routes, right? They'll either say, we need a centralized data analytics, AI, machine learning team, or they'll say, each team should have an embedded data analytics machine learning team, or to be some level of a hybrid model, right? To say we have a centralized one, but that centralized one is just the hub, and then we have these satellite teams in the different, embedded in the different business units. Again, there's no way to really say which way is right or wrong, right? Depending on the industry, that could work for a specific company, whereas another one might have a different way of doing it. But the thing is to be able to figure out which works best, and then also to not be too rigid in terms of structure and governance, but also be able to, alternatively, be able to try it, right? Go from an agile approach, go from an experimental approach as opposed to a risk-averse and fear-based approach. But again, the value there is starting small, right? We had an opportunity to save a lot of money with our machine learning model, but we had to start small, right? We couldn't jump to full production and say, hey, we millions of dollars, right? It needed to start small and scale up. So, yes.
Since it sounds like you productionized it, can you talk a little bit about the ML ops portion and how you're maintaining that model performance over time?
Yeah, so I was part of the development. Once it was built, it was handed off to the engineering team, and they kind of implemented their own ops. We do have regular touch points with them to determine the outputs and determine whether or not it's still functioning appropriately. And we have different quality gate checks that we go through monthly with them. There's also a forum that we have implemented to for them to speak to how things are going, how they scale it up. But once we had it functioning, I actually passed it off. So it wasn't.
Just curious, are you doing like retraining? If you had to do any of that with the model?
Am I training?
No, retraining the model or anything like that?
Yeah, we the conversation is up. We haven't necessarily started it just yet, but there are plans to retrain it as well as to expand to do the hyper tuning parameters in order to expand its capabilities for a few other to get some additional outputs that could be more effective in terms of what we could do. So a change from a certain percentage to a different percentage of return on that investment. So, yes. Okay. Ma'am? Oh, you're waiting on the mic. Okay.
I work for a small business lender, and we are currently beginning to leverage machine learning for some of our underwriting processes. Some of those processes, the results of the models go to a user, so they see the results of them. It's human nature where you would really only notice when the model is wrong, and that's the ones that they remember, and that's the ones that I hear about. Do you have any advice on how to build that trust with the users that see the results of the model to, I guess, trust it? Obviously there's lots of stuff in the background, continuous improvement, retrain the models, all of that good stuff. They don't obviously see that. So how to communicate or better show to the front-end users who are not technical or data science minded that the model will be wrong sometimes, and that's okay, but overall it is still highly effective.
Yeah, there's really no straightforward answer for that, right? That really comes to kind of shifting the culture and telling that compelling story, and really hammering home that this is we're in a transformational period, right? Numbers are good, right? So if you can say, hey, it's been right X amount of time and has only been wrong for this percentage of its function, that typically is a really good determiner on how effective it is, and that really drives points. People respond to numbers, but there's really no way to say, hey, yeah, this is what I tell them. It really just comes down to how effective a storyteller you are and what type of numbers you can put behind it in terms of success versus failure.
So my question's very similar in nature, so maybe a little slight twist to it, but generally I'm wondering how you would gain confidence, if you can speak to maybe best practices or an experience you had in terms of gaining confidence of decision makers to move forward with these models that you've created.
So there's a really good analogy that Chris Rock gave, okay? And he says that before he was famous, when his car used to break down, he would stand on the side of the road and try to flag people down for help, but no one would stop. No one would stop to help him until he started pushing the car himself, right? So really, they kind of need to see motion before they get on board with what you're trying to do. So if you can deploy something with, say, some training data or in a quality environment and show an output, then you can extrapolate that out in terms of your messaging to a decision maker to get them on board a little bit more, because you're not going to sell them on concept alone. You'll have a lot of, at least in my experience, you won't sell them on concept alone. Everyone around you might say, hey, we think it's really cool, we should do this, we should try it. But that top person, that CEO who has a board to appeal to, or that director who has bottom lines to meet, they're not going to risk it, right? So you need to be able to show numbers to be able to show that there is momentum and that there might be treasure on the ground there, as opposed to just saying, hey, we should start digging and hopefully we find treasure, you know? Yep. Okay. Anyone else? Okay, well, thank you all for your time. It was great to speak to you here, and hopefully we can connect later. So. All right, thank you.